Okay, looking at our notes today, we have we're going to look at secants and tangents and how to find angle measures and arc measures. We have specifically three theorems that we're going to be looking at. The first one is when the two secants or chords intersect in the interior of a circle. We have an example of that right here. See how they intersected inside of the circle? Well, when they intersect inside of the circle, then the measure of the angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angles. So basically what we're saying is, let's look at this example down here, right below. We're going to find the measure of this arc. Well, the angle formed by these two chords intersecting at this point right here is equal to, so 60 degrees is equal to 1/2, sorry, let me erase that, 1/2 times the sum of the two arcs intercepted by those two chords. These two arcs that I've drawn in red, which are going to be x plus 25. And if we wanted to write our formula for that, we would say that angle 1 here is equal to 1/2 times the sum of the two arcs. So AB plus DC. You can read that. AB plus DC. So we see that here. How do we, instead of distributing this 1/2, which we could do, it's much easier to multiply both sides by 2. 60 times 2 is 120. And when we multiply 1/2 by 2, it cancels them out. It equals 1. So we end up with x plus 25. We'll subtract 25 from both sides, and we end up with x equaling 95 degrees. So that's the measure of arc JK, or x. So let's look at the next example. So here we have angle Z, what we're looking for. Notice I have the arcs of these two, so it's possible to find this angle. And when I do, I could always say that it's supplementary to angle measure to find x. So remember, our angle, which we're going to look at, change color, there's too much blue going on here. We're going to look at this angle right here, and the angle formed by the chords, this arc and this arc. So angle Z, we'll call it, or we'll just call it angle Z, or we'll call it VZW. That way we don't mistake it for something else. Is equal to 1/2 the sum of the two arcs. 96 plus 62. Well, if I add 96 plus 62, it is 158. When I multiply that times 1/2, the measure of angle VZW equals 79. So this angle is 79. Now remember, it's going to be supplementary to this angle, so we can just subtract 180 minus 79, giving us 101 degrees. That's what x equals. Okay? Now remember, this is the theorem we use. We take 1/2 the sum of the arcs to find the angle when the arcs intersect inside of the circle. When I'm sorry, when the chords or secants intersect inside of the circle. On the other side of that, here, let's look at our next example. Sorry, just trying to get it right on there. Now, here we have if they intersect at the point of tangency, which basically means if the lines intersect at one point on the circle, if they actually intersect on the circle, not inside but on the circle, then the measure of each angle is 1/2 the measure of its intercepted arc. So basically it's just half of the arc when they intersect on the circle. So looking at finding A here, they intersect on the circle, so the measure of this angle, QPS, is equal to 1/2 the arc, the intercepted arc. Well, the intercepted arc is this arc right here. It's the arc inside of the angle, which is 250 degrees. So 1/2 times 250. Well, when we multiply that, we end up with 125. So angle QPS equals 125 degrees. That's a pretty simple one to do, this second theorem. So now we have another one. This one wants us to find the arc. Well, remember, the angle 108 is equal to 1/2 the arc, which we'll call x. Multiply both sides by 2. Cancels the fraction out. Gives us 216 equaling x, which we said the x was the measure of arc BC. And actually, I take that back. BCD is not the arc that we were looking for. BCD is this arc. So if 216 is arc DB, we have to subtract 216 from 360, which gives us 144. That's the measure of arc BCD. This is 144. The other arc is 216. And the third one is when the two lines, the secants, tangents, whichever they are, they intersect in the exterior, outside of the circle. So the first one was inside, the second one was on, the third one is outside of the circle. Then the measure of the angle formed is 1/2 the difference. So, for instance, here we would say that angle A is equal to 1/2, and the difference of the intercepted arc, you take the larger arc, DE, you subtract the smaller arc, BC. Okay, this second example, that would be angle A, still is equal to 1/2 times the larger arc, DC, minus BC. And then this last third one, angle A would be equal to 1/2 arc BCD, and we're going to name it with BDC, sorry, BDC minus BC. Okay, so let's look at an example of those. So here we have the angle measure, which in this case is 62. 62, the angle, is equal to 1/2 the larger arc, 141, minus the smaller arc, which we don't know, so we'll just call it x. Get rid of the fraction by multiplying by 2. Cancels the 1/2, and 62 times 2 is 124. Solve for x, you end up getting x equals 17. That's the measure of arc BC. Okay, let's look at the second question here. Okay, we have our angle, which in this case is 40. It's equal to 1/2 the larger angle, or arc, which we don't know what that is. We'll call it x, minus the smaller arc, which is 140. Multiply both sides by 2 to get rid of the half. We end up with 80. I'm sorry, I shouldn't have scratched that out. That would scratch out. 2 times 40 is 80, equals x minus 140. Add 140 to both sides, and x equals 220, which is the measure of arc x, y, z. Okay, and the last example. Here, again, they intersect on the outside, so we have the angle measure, which we don't know. That's what we're trying to find. We'll say angle S equals 1/2 the larger arc, 179, minus smaller arc, 71. When we do that, we end up with 1/2 times 179 minus 71 is 108. And then when we multiply 1/2 times 108, we find that the measure of angle S is equal to 54 degrees. Homework shouldn't give you a problem. Number 6 might be the only one that does, so let's take a look at that one. Notice they intersect in the exterior, so which one are we going to use? We're going to use the difference. So the arc measure is 65. It's equal to 1/2 the difference of the larger arc, which we don't know, and we don't know the smaller arc. Well, if we are looking for arc DF here, what would the larger arc be if the smaller arc is x? If we're looking for this, if we had a number, we would just subtract it from 360. So we'll say that 360 minus x is the larger arc. So once we have that, now we have to subtract the smaller arc, which we labeled as x, and we end up with that. Multiply both sides by 2. Gets rid of our fraction. We end up with 130 equals 360, combine the terms, minus 2x. 2x equals 230. When we solve for x, x equals 115. That's the measure of arc DF, which is our unknown. Just looking at some of these problems, look at number 1. It intersects on the circle, so that will be the second theorem that we learned. Number 2, it intersects outside of the circle, or the vertex of our angle is outside. It's going to be the third theorem. Intersects inside, it's going to be the first theorem. It's on the circle, second theorem, and so on. So use these. There were 3 theorems. They all depend on where the vertex of the angle is, whether it's inside, outside, or on the circle. Okay, that's it.